Welcome to Chips on Math Physics. Today we are going to be dealing on trigonometric identities, part 3. We have the first part, the second part, and the third part. The first part I deals with the introductions, what it means to prove identities, the approaches and guidelines. The second part we start with many examples, and this is the third part we are going to be dealing on some complex analysis and how we can actually prove a trigonometric identity. So let us just jump into it. We're having a question before us. We are to prove that cos x plus sec x, that is cos x divided by secant x plus sin x divided by cosecant x is equals to 1. Of course, we know that if this is equals to 1, we have to know that there is this particular identity, and this particular identity is very important. This sin x cosecant x is equals to 1. So we can as well say that all this identity in the left hand side is equal to sin x cosecant x, because cosecant x sin x is the same as 1. But before we can prove this identity, I would like us to prove that sin x cosecant x is equals to 1. So let us see how that goes. Remember, like I said, sin x cosecant x is equals to 1, and that comes from sin x. The identity sin x itself is 1 over cosecant x, and if we multiply both sides by cosecant x, we will simply have sin x multiplied by cosecant x is equals to 1 over cosecant x multiplied by cosecant x. Now, cosecant x can actually cancel, so that we are left with sin x multiplied by cosecant x, which is equals to 1 that is remaining. And this multiplied by this will give us sin x cosecant x, which is equals to 1. Now we can actually try to solve the problem, because the equation says that we prove that sin x divided by cosecant x plus cos x divided by sec x is equals to 1, or sin x cosecant x. So let us see what we can do here. We have sin x divided by cosecant x. We are going to multiply by sin and cos, so that we will have sin x divided by cosecant x multiplied by sin x divided by sin x. Of course, this will be plus cosecant x divided by sec x multiplied by cos x divided by cos x. All these will be equals to sin x cosecant x. Remember, sin x cosecant x is representing 1, as we already proved. So now we know that sin x divided by sin x will give us 1, because this will cancel and you are just having 1. Cos x will divide by cos x and you have 1 as well. So now we will have sin squared x divided by cosecant x sin x plus cos squared x divided by sec x cos x. All this will be equals to sin x cosecant x. Now we can have sin squared x divided by 1 plus cos squared x divided by 1 to give us this identity, which is 1, or sin x cosecant x. But since sin is squared and cos is squared, all of them will give us 1. So we will simply have cos x divided by sec x plus sin x divided by cosecant x to be equals to 1. And this has proven that sin x, as we see in the identity, that cos x divided by sec x plus sin x divided by cosecant x is equals to 1. It is just a bit tricky when you are given something like this and you are required to prove that the identity is true. But you don't need to cram it, you simply need to follow the patterns and go with the concept, and you are good to go. And this is how we prove identity. See you in our next video, and don't forget, subscribe. Thank you, and God bless you.